Alright, mixed practice, day 2 from lesson 1. We're going to look primarily a lot at exponent rules, okay? So I have 3a squared times 5a to the 4th. What do the 3 and 5 become? 15. Now I have a squared times a to the 4th. What does that become? A to the 6. Perfect. Because when you are multiplying things with the same base, you add the powers. Let's move on to the next one. 3c to the 5th quantity raised to the 2nd. My question to you before you answer this is, how many terms do you see in parentheses? Some people say 2. Some people say 1. The correct answer is 1, because terms are separated with addition and subtraction signs. And this is a huge, common, simple error that people make in the regard of this. The 2 will be applied to all the pieces of the one term, like this. So that the 3 becomes what? 9, and the c becomes 10. Because powers raised to a power, you multiply those two numbers. And a good way to remember that is the parentheses typically means multiplication for the most part. Okay? Now, the common mistake people make is this, is that if you had 3 plus c to the 5, I'm changing it up just a little bit, because of this addition, or it could be subtraction, you now have 2 terms. So think of them as two islands, if you will. So if you have 2 islands, my question is, does this get applied to both of them the way it did here? No. And it doesn't, okay? Multiplicity says that this right here will be 3 plus c to the 5th times 3 plus c to the 5th. Almost like a foiling method, if you will. That is a common mistake. If you know it, you're good. If you don't know it, please make note of that in your notes, okay? Alright, so let's come over here. How many terms did I just box? 1. Because it's all glued together with multiplication. These are huge, again, simple errors. So can I reduce right now? Yeah, so 18 over 3 becomes what? 6. And what does the z's become? Z to the 4th. If you follow the rule, it's going to be z to the 7th minus z to the 3. We talked about this, I believe, yesterday. It's like having 7 z's up top and 3 z's on the bottom. These 3 z's cancel to forms of what? 1. So you're left with the top wins. Okay? I know these are easy, guys, but it's just the fundamentals so that the harder ones are also easy. Looking at this, I'd probably look at 25 and 5 and immediately see that it reduces to 5 over 1. What would be the next thing that you think we should do? Flip it, right? Make the negative powers move. So d to the 1 would go upstairs, a squared would go downstairs, and c to the 4th would go downstairs. And as you move them, they are becoming positive. So you have a squared, you have c to the 4th, the b cubed is still remaining upstairs, and you have d to the positive 1. Can anything reduce? No. So the only thing that probably you don't have to do and that you won't see is that d to the 1 power. It's just understood, and that could be your answer. Okay? Let's move on to 4. Please think about it. Think about the errors, the simple errors. What's the answer to number 5? 16 to the a plus c. Now, why did you say 16? A lot of you said 16. What if I told you it's not 16? What do you do with powers when the base is the same and you're multiplying? What do you do with the powers? You add. So the answer should have been what? 4 to the power of a plus c. Okay? A lot of people might have missed that one, okay? So please, please be careful on that. Can someone tell me what would you do to this in order to make 16 to the a plus c actually happen? It's a little extension. I didn't ask that earlier today. But what could you do to this to make it 16 to the a plus c? So if it's, first of all, 4a, this is a really good question, I didn't even plan on it. 4 to the a times 4 to the c, you agree is this right here, right? Okay. He just said you could multiply the whole thing by 4 and it would make it 16 to the a plus c. Raise your hand if you think that's true. So it wouldn't. It wouldn't. So if I have 2 to the power of x and I multiply it by 4, this is not equal to 8 to the power of x. Can someone tell me why? Exponents are done before multiplication. PEMDAS says this would be done first and then you would multiply the 4 with the whole thing. This is a common error that even it took me a higher level math to find that and actually understand that, okay? So I think we can do that now, that 4 and the 2 would not combine, okay? And that's what I call a good mistake because a lot of people don't know that, okay? And if you make that mistake, that's okay because it brings awareness to that. Number 6, what would that become? Don't be afraid now, come on. What would 6 become as far as the answer? A minus b, yeah. Just one x though, right? So the a minus b, the x's do not cancel. Yes?
Just real quick, how do we make it 16a plus c?
Okay, so you wouldn't, there's not a way because
okay.
The only way that I would think is to like square everything. But as soon as you square everything, this is like squaring it here. But it still doesn't make it that because it would, what would this be? 4, nice question. 4 to the a plus c all raised to the power of 2. What would that become?
4 to the a plus c times 2. We'll put like a, d, and c in parentheses.
Good. 4 to the 2 times a plus c. Otherwise, 4 to the 2a plus 2c. Okay? Nice. All right. 7. What's the answer to 7? 2a times b. This is what you said. So try it again. 2 to the power of ab. So 2 to the power of ab. Yep, ab is multiplied. Let's look at this one here. B's, who wins? The bottom one by how much? 2. Because otherwise you would say this. And some people struggle a little bit with that. They forget to move it downstairs and make it a positive. Okay? Because right now that's like in the numerator for both of them. And then you'd have an a to the 7th and an a to the 4th. Who wins? The top by 3. And this would be your most reduced answer. Okay? This one right here is the cubed root of 27 to the power of 1. And it would be 3. Okay? Remember, this is 3, but I want you to remember something real quick because you'll have it on your quiz today. You can look at this, otherwise this, 2 ways. You can look at it as cube rooting 27 first and then raising it to the power of 1. Or you can look at it as 27 to the power of 1 and then cube root afterwards. Order does not matter. Why? It's multiplication. Good. All right, 10. X to the power of negative 1/2. What would y'all do? So first we got to move it, right? Always move those negatives before square rooting. So this is over an understood 1, right? So when I move it down, it will become x to the power of 1/2, and a different understood 1 that's already there as a coefficient is now going to appear. And then now you take the square root. Actually, do you think you'd probably see this as a multiple choice answer? I mean, you could, but most likely you wouldn't. What would you probably see this as? The square, okay, so people are thinking this. And you learned it in Algebra 2, I believe? You'd have to rationalize. So you're going to multiply by a form of 1, which is what? Square root of x over square root of x. So your final answer most likely would look like this one right here. And you see a lot of that like in pre-calc. Okay? Alright. Angles of parallel lines. There was a bunch of words, a bunch of fancy words with this. but can someone tell me what were the two things that you were talking about when you looked at a picture that looked like this? In other words, I could pick any two angles, like 1 and, give me a number. 3? Okay, so 1 and 3. Supplementary. Let's pick two other angles. Any of them. 1 and 6. Supplementary. So what is this going to be? What's the other thing that it could be? Not complementary. Equal to each other. Okay? So you could say like 1 and 4 are equal. And what I'm trying to show you is that this figure, there are basically two answers that you're going to have. The two angles are either going to be equal, or the two angles are going to be supplementary to each other. Let me tell you a misconception that I used to have when I was your age. When I had adjacent angles like 1 and 2, I said 1 and 2 were supplementary. And I was correct. 1 and 2 are supplementary because they add up to be what? 180. But I thought that they had to have an adjacent touching side. So 1, okay, and 7, although they do equal 180, I didn't think they were called supplementary. Do you understand? And the answer to this is they are called supplementary. So supplementary angles don't need to have this adjacent side that touches. They could be way far away from each other as long as they add to what? To 180. Okay? Alright, so there's one more thing that I want to kind of help you out with this thing, with this whole diagram so that the words are easier. It kind of shows students that these are like sidelines, let's say, to a football field. Just to remember how to label them. This is the playing field, obviously. So this is inbounds. Otherwise, the interior of the field. And this right here had a fancy name, just saying draw the line between the two teams. This is your transversal line, right? But this would give me the alternate. So if I'm not on this team, I'm on the alternate team over here. You with me? And last but not least, the out of bounds are just saying it's the exterior of the field. And hopefully that helps you, okay? One last thing. From all the angles that you see, there are two types of angles that are up there. What are the two types of angles that you see? Don't be shy. Acute angles and obtuse. So sometimes looking at these, I remember getting a little confused. Is that going to line up and add with the other one to give me 180? You see what I'm saying? And here's your shortcut. If you have two acute angles, let's say 1 and 8, which one of these two are they? They're equal. How about if you had two obtuse angles? Which one of these two are they? Still equal. But if you have an obtuse and you have an acute, they're going to add to be 180, which is supplementary. Okay? Now, hopefully you've seen it a little bit differently, kind of stacked on knowledge that you already know. And now let's look at 1 and 4. 5 and 8. 1 and 4, 5 and 8. 2 and 3, 6 and 7. They're all equal. Why? What do we call those angles? Vertical angles. And they are equal. Now we have 3 and 5 and 4 and 6. What are those called? Okay, so look at the field. They're not opposite. It's either alternate, same side, interior angles. Okay, so same side, interior angles. Are they equal or 180? So some people are hesitating a little bit more. Look at 3 and 5. You have an obtuse, you have an acute. So they're 180. You might see this, I doubt it, because when it was back when I was your age, which was ages ago, they used to call 3 and 5 and 4 and 6 consecutive angles, which made no sense. Like consecutive, I'm thinking 4, 5, 6, or 10, 11, 12. You know what I mean? Not, okay, 3 and 5, that's consecutive. 6 and 4, that's consecutive. Okay? If you do on ACT, that's what consecutive means. Otherwise, they'll say same side interior. Okay? Alright, so let's look at 1 and 2, and 6 and 8. What are they? Supplementary. Why? They add up to 180. Or you can also say they're adjacent angles. And adjacent means they're touching. If they form a line, they are 180 supplementary. All right, here we go. What other angles are congruent to each other? So let me clear this up just a little bit, but I want you to remember interior, exterior, and alternate. Remember, alternate means you're playing on the other side of the team, otherwise on the other side of this transversal. So what other pairs are congruent?
3 and 6.
Sorry, I gotta put that real quick. 3 and 6, yeah. So 3 and 6. And are they equal or equal 180? They're equal, duh, I just said it, congruent. And what are they called? Alternate interiors. No worries. Alternate interior angles. Okay? Opposite is like this. Like, can you tell me what the opposite of 1 is? -1. You know what I'm saying? So opposites, they add to 0. Okay? Can you tell me, are those opposites? They're reciprocals. And they multiply to what? 1. Reciprocals multiply to 1, opposites add to 0. No, it's okay, it's okay. You're not the only one who's said that. What other pairs are congruent that you see up here, guys? 3 and 7, yes. 3 and 7. And what are those called? Someone said it.
Corresponding.
Yes, corresponding. I think there's one more.
7 and 2.
7 and 2 or 1 and 8, right? So let's put 7 and 2. And they are equal. What are they called?
Alternate exterior.
Alternate exterior. Nicely done. All right. Cool. Any questions, guys? Okay. Let's move on to solve using the quadratic formula. Now it's subtle, but it's huge and important. My question to you is this. How do y'all know when to use quadratic formula? First of all, that should be your last resort, right? Your very last resort, because it takes forever. And you should know how to factor by hand with number sense fairly quickly. And we're going to practice that. But my question back to you is, when do you know, or how do you know to use quadratic formula?
When it doesn't factor completely.
When it doesn't factor easily, right? Because this 2 is here, should you by default use quadratic formula? No. No. So you know that there's a factor by grouping method. There's something even faster that I'm going to show you today. It's even faster than factor by grouping method. My second question to you is this. When you factor quadratics, must you, is it required that you always set it equal to 0? So some people know, some people don't know. Okay. The answer is you don't have to always set it equal to 0. Okay. For instance, check this out. This, let's say that we had 1x squared and we had minus 9. What is this factor to? Difference of squares, right? I heard it. We know to set it equal to 0, but my question is, first of all, what's this answer? -3? +3? My question to you is, did I have to set it equal to 0? This, if you know the answers to these subtle questions, not only do you have it mastered, but you're going to be faster than other people, okay? You didn't have to set this equal to 0. You could have if you wanted to, after that. But a lot of people forget this. Right? Here. They forget that. Okay? So then it would have been plus or minus 3. You with me? Now, I'll ask you again. When do you know that you must set it equal to 0? Kind of based off of what I used with this thing. Don't be afraid to answer, because some of you might already know. When must you set it equal to 0 so that you don't accidentally cancel half of your answers? So no one knows it, please write it down in your notes. When you have an ax squared and a bx, you need to set it equal to 0. Let me give you an example. If I had 2x squared minus 4x, oh, it's right there, duh. I would have to set this equal to 0. Okay, I'm doing a different problem slightly because I'm not messing with the 1, okay? I will have to set this equal to 0. Because most people forget the easiest step, which is next. Three-letter acronym. What are we supposed to do right now? What are we supposed to do to factor this? GCF, right? We're going to take out a 2x. So what's left? X minus 2, right? So you have 2x, you have x minus 2. They're multiplied. So what would the answer be right here for this x? 0. And this one? 2. Now look, if you didn't set it equal to 0, I've seen this in hundreds of papers that I've graded. And also on tests, they'll put one answer, they'll put two answers, which one's extraneous, so on and so forth. You see where I'm going with all this? So if I have this right here, some people would have done this. And their answer choices look like x equals. And then they would look like, maybe if I take this out. Okay, so 2x squared, if I wanted to get x by itself, I would divide by 2x on both sides. What would be left on the right side? Just x. What would be left on the left side? 2. But I only have one answer. So please make note of that if you don't know it, because extraneous solutions, these are easy questions that a lot of people miss because they don't know how many answers to look for and in what ways, okay? If you have an ax squared and a bx term, you must set equal to 0 in GCF. Okay? Other than that, you could just remember plus or minus whatever you got. Any questions from that? All right, so let's go ahead and answer the one that's dealing with this 1 now. Okay, so I have 2x squared minus 4x minus or is equal to 1. I'll ask you again, we just talked about it. Do I have to set this equal to 0? Don't be shy. Yes. Because I have an ax squared and a bx. So when I set it equal to 0, it will look like this. And just like it was said, we're going to try to factor this. Okay? So here we go. This is an easy one, but the mechanics are the same, and I'm showing you with an easy one so that the harder ones, you do the same stuff and it's easy, okay? Here we go. This is how I would like for you to factor, instead of factoring by grouping. I know that these two numbers multiply to get 2x squared. So I do 2x and x. I also know that these last two numbers will multiply to get a 1. Notice how I didn't highlight the negative 1. Not yet. What are factors of 1? 1. Just 1 and 1, right? So it doesn't matter right now where I put that. Do you agree? Now, these two numbers in green will multiply to get a negative 1. So I know one is positive, one is negative. But at the same time, I'm aiming to get a negative 4. Watch. From the outside and the inside. So as you're assigning these negatives and positives, I know this is the first one I've shown you and it kind of feels like it's a longer problem. It won't be, especially with the harder ones. Could you arrange a positive and negative that would make not only this multiplication of a negative 1 work, but also give you a 4? Let me show you what you should be looking at. 1 and x is just 1x. 2x and 1 is 2. So this is this extra bit that I'm trying to show you. The 1 and 2 will either become a 3 or will become a what? 1. Are any of these numbers the one that we want?
No.
No. That's how we know to use quadratic formula. They're just quick number sense checks that aren't with huge numbers that you are more than capable of doing. In my opinion, my experience, much faster than if you're trying to do factoring by grouping. Okay? Alright, so this is non-factorable in that respect, so we do have to do the quadratic formula. And yes, we'll fly through this because it's not too bad. But I also want to make sure that you don't run into an easy mistake on the quadratic factoring. Here we go. What's A? 2. B? Negative 4. C? Negative 1. So you have negative B plus or minus B squared minus 4AC. Okay? All over 2A. So, let's go to the radicand. We have negative 4, positive 2, negative 1, which is a positive 8. We also have positive 16. Okay? So we have root 24 underneath. We have 4 in the denominator and a positive 4 number over here because this double negative became a positive. Alright. Can this reduce?
Yes.
Yes. Before we reduce, let's simplify our radical. Okay, we talked about this yesterday. I want to break up 24. Let's see if you remember. What's the first number that I'm thinking of? 4. Thinking of 4, because that's 2 squared. What would be the next number that I would be thinking of? 9, because that's 3 squared. And then 16, 25, and so on and so forth. Okay? So if I divide this by 4, you with me? I'm going to have 6 and 4. Does 6 come out? No. But 4 does. So you're left with that. Do you agree? Okay. So how does this reduce? Say again?
Divide everything by 2.
Divide everything by 2. Besides the radical. Good. So he reduced the coefficient of root 6, this 4, and the denominator 4. Perfect. Is this as low as it will go? Yes or no? Yep, that is. That's the lowest that it'll go. Some people might have chosen, though, to write this as 2 over 2 plus root 6 over 2. So it would be 1. And I think that's what you were thinking. So that could be an answer as well. 1 plus or minus root 6 over 2. Any questions from that, guys? Okay. Alright, so let's go to the bottom piece. The bottom piece is using function notation algebraically. Now, the shortcut that I'm going to show you with this, called synthetic substitution, you're going to look at this and you're going to be like, that's easy. I don't need to use synthetic substitution on that problem. And you're right. But that's not why I'm showing you this. I'm showing you for the more difficult ones, that it might be x cubed, have bigger coefficients like 27, 54, whatever. Synthetic substitution will be faster. Now, the reason why this, although it looks real simple, is on the PSAT is because students will do this. Now think about the mistakes that students could make. What do you think their answer would be if they made the mistake that I'm thinking of? 3 times negative 9. That's a negative 27. Minus 5, they would put negative 32. And that would be wrong. Because they forget parentheses, right? Which means this is a multiplicity of 2. So the negative times the negative is actually a positive. So it's 27 minus 5, which would be 22. Some of you might even write this answer like this. Both mean the same thing. At x x is equal to negative 3 on the function f, the y value is 22. Okay? Now, the synthetic way that I would want you to do it is like this. And I teach this every year, especially to my calculus students. They don't jump on board at first, but then they see the problems that they have later on that are non-calculator based, and they then go to them a little bit too late. So please try to do it a little early. 3x squared, I'm going to write 3. I have no x's, so I'm going to write 0. And my constant is negative 5. I'm going to plug in a negative 3 into this synthetic substitution. These are the methods. This is a pre-cal in case you're wondering. You copy, multiply, add. Multiply the new one, add. And this is your answer. That's called synthetic substitution. If this came out to a 0, that's factoring, and that would be synthetic division. If you don't understand that, no worries, that's pre-cal, that would be coming, okay? The synthetic substitution you can definitely use. Questions? Okay, so here we go. In layman's terms, someone please tell me what is that asking for that I've just highlighted, and be as detailed as possible. Talk to me like if I'm a 6th grader. Anyone?
You're finding the y value where the function g of x is, where like the x value is negative.
That was perfect. So what is the y value on the function g when x is negative 4? Okay? Anyone, what's the answer? 3. What's the g of negative 1? 2. What's g of 0? 1. And g of 3? 5. Another volunteer. Who wants to say what that is looking for?
What is the x value, or what is x value of g function?
Yep. So what is the x value, right, on the g function when the g function is equal to 3? So let's set our y value on g as 3. Okay? You're going to tell me when that graph is 3. What would my answer be? Anyone? Okay, so some people are listing them out like this. Negative 5, negative 4, negative 3, negative 2, and 1 half. And you're listing them discretely like individual pieces. But what they actually want you to do is know that there are decimal answers in between these integers. So you would actually do negative 5 all the way to negative 2 inclusive on both. And then union with, you could say k equals 1 half. Or if you wanted to, just as an element, just say 1 half. Oops, I don't know why it keeps doing that. Questions? Good? Remember, we're going for mastery, guys. We're not going for trying to get a 90 on a test. We're trying to get a 99.5 on a test, okay? Yes?
Why do you do union with?
Just because it's inclusive. It's saying that all of those are possible answers for K. Okay? Alright. Sine, cosine, and tangent. Given the figure to the right, the trigonometric ratios of the angles B are as follows. If you are sitting right here at B, this is correct. You with me? But if I said, what is the sine of A? What would you write based off the graph? That'd be weird, right? You can no longer put adjacent here. You with me? Okay? So what I'm trying to show you is that these are interchangeable depending on where you're at with the angle. Is this interchangeable? No, that'll always be the same. Okay? So just to master this a little bit more, what I want you to do is, in your notes please, I want you to go ahead and change this to one of the Pythagorean triples that we learned this week. What was the easiest, most common Pythagorean triple? 3, 4, 5. So 3, 4, 5. Okay? Alright, so 3, 4, 5. What would the sign of A be? Four-fifths. That's the opposite over the adjacent. What's the cosine of A? 3/5. And some of us might be a little slow. So, ka, toa. We know the hypotenuse is always there, and the adjacent and the opposite depend on where we're at. So what I would like students to do most of the time is find the opposites as far as wherever you're at. So if you're at A, this would be the opposite. Okay? So cosine is adjacent over hypotenuse, 3/5. Anyone, what's the tangent from A? 4/3. Alright, so let's change it up. What's the sine of B? Don't be shy. What's the sine? Otherwise, what's the opposite over hypotenuse if your body is at B? 3/5. Okay, imagine the body. That might help you a little bit more because you're answering faster. What's the cosine of B? 4/5. And what is the tangent at or from B? 3/4. Notice the relationship that this is saying down here. Guys, the sine of A, so the sine from here is actually the same as the cosine from the other angle. And you'll see this a lot camouflaged on stuff. Okay? Just like the cosine on A is the sine of B. And what relationship do they share with the tangents? They're reciprocals of each other. Are we good? Okay. Let me give you something. Let's see. What if you had something that looked like this? The sine of A, okay, we'll say that the sine of A is equal to 0.6. What would be the cosine of B? Okay, oh nice, nice. You remember that very quickly. Because the sine of one is the cosine of the other. And I've seen that in a lot of ACT tests. If they are feeling extra difficult, what would that be? So this one's a little bit different. Think about it. You need to be thinking about it. Actively jump in there. Sine from A is 0.6. So what's the sine of B? What'd you do?
So 0.6, you plug in 3 and 5.
So 0.6, look at this. So 0.6 is the same as 6/10, otherwise 3/5. And when you plug them in with sine, it's opposite over hypotenuse. Nicely done. So when you do Pythagorean theorem, you recognize that this is a 3, 4, 5 right triangle. I know it's not drawn to scale. They won't ever be. But if you wanted to try to find the sine from where angle B is at, which is opposite over hypotenuse, it'd be 4/5. Nicely done. Alright, so let's move on. We're going to do some fractions and then we'll take a quiz. Now with fractions, we've added fractions since 5th grade. Again, I'm not here to teach you to add fractions. I'm here to refine and speed it up, okay? With low error. 5/9 plus 1/9, can I add them? Yes, because common denominators say so. So 5 plus 1 over 9 is 6/9, which you would write as 2/3. Okay? Next one, I can't add them yet. Because of what? No common denominator. So when I don't have a common denominator, you tell me, can I multiply by forms of 1? What's the first form of 1? Don't be shy. 2 over 2. What's the second form of 1? 7 over 7. It's what the other one didn't have. So now my common denominator is 14. You with me? So I have 4 over 14 minus 21 over 14, which is 4 minus 21 over 14. What's 4 minus 21? Negative 17. And this one does not reduce, and that would be your answer. I hope that you adopt new ways to do stuff so that you're faster, more efficient, and more accurate. Here we go. Let's cross multiply up. 2 times 2 gives us this 4. Let's cross multiply up. This gives us 21. The sign in between is subtraction. And then let's multiply the denominators together to get 14. Cross multiply up, cross the denominators, multiply them, and you get to the answer very, very quickly. Okay? You will see that on today's quiz. Please try it on for size. The times that you should be trying all of these suggested methods should be on your homework. We're going to take a quiz before you do lesson 1 full homework, but that's okay. Other ones will do the homework before we take the quiz. Alright, so this one, we're not going to do this method because we really only do that when we have 2 fractions, okay? Since we have 3, let's go ahead and just blanket and get our common denominator, which is what? 6. So, forms of 1, here we go. The first one, we're going to multiply by what? 3 over 3. This last one, we're going to multiply by what? 2 over 2. Notice that I have 3, oops, not that one, 5 and 4. So just go ahead and write it. 3 plus 5 minus 4 all over 6. So what's my final answer reduced? 2/3. Nicely done. Because it'd be 4/6. Questions? Fairly simple. Do I need common denominators for multiplying and dividing? No. But I'm going to be looking for cross reduce, otherwise reducing to forms of what? I keep repeating a lot of stuff because they all tie together. Forms of 1, right? So reducing forms of 1. Guys, could I have written this like this? Can I do that? Why can I do that?
Because it's commutative.
Yeah, because it's multiplication, commutative, order does not matter. How many terms do you see, guys? 1. It's all one term glued together with multiplication. So order doesn't matter. That means I could do this if I wanted to. Okay? So this cross reduce, what it means is this. Don't do that. And just reduce 6 and 3. You see what I'm doing? To 2 and 1. So now I have, whoops, I didn't want that. Now I have 4 numbers. I have a 2, 2, 7, and 1. Can anything else reduce from top and bottom? No. Now is when you multiply straight across to get 4 and straight across to get 7. So that you get 4 sevens. What I hope you don't do is, unfortunately, in 5th grade sometimes they teach us just multiply straight across and then try to reduce. You're a little bit too late, okay? That's harder to reduce, especially when they're bigger numbers and they have x plus 5 or x minus 25 and other stuff. Try to reduce as early as possible. More of the story. Look at the next one. What numbers do you see that can reduce now?
10 and 4.
10 and 4. Here we go. This is now 2. This is now 5. And I want you to do this on your quiz today, okay? What else? 2 and 26. Now what? The 13s. So I have a 5, 1, and a 27 left. That's it. There's nothing else that can reduce. So now multiply straight across. Done. Do we agree? Okay, let's do the last one. I know this looks a little bit weird. Sometimes you'll get fractions that look like this, or fractions that look like this. Are these two the same? Did someone say yes? It's okay, I'm just trying to see what the answers were. This is 2 divided by 3/4. Okay? Which would be 2 times 4/3, which nothing reduces. This is 8/3. Over here is 2/3 divided by 4, which is the same as multiplying by 1/4, which that would reduce this to 2, which is 1/6. Although they kind of look like the same, why are they different answers?
This division is in the
Because division is not commutative. Division order matters. Nice. So they're subtle, guys, but these are huge things that I'm asking you as far as how well you know the stuff. So divided by 7/18 is multiplying by 18/7. What do y'all want to reduce? 15 and 20. Which go to what? 4 and 3. What else do you want to reduce? 21 and 3, or look at this. Check this out. 21 and 21. Let me show you that again. 21 is right here, because it's multiplication, and 21 right here. Okay? Now what? 3 and 18. So what's my final answer? 24. Questions? Please, if you have questions, please don't be shy. Ask them so that you don't make that mistake on the test. Good? Alright. Alright, let's go to number 7. Look for opportunities to cross-reduce still, even with variables. Okay? Tell me what to reduce, guys. Forms of 1. 5 and 2. 5 and 10. I'm going to do this again, okay? Watch very carefully, because I might have gone a little bit too fast the last one. This 2 and 10 are 20. Fewer errors if you can group stuff faster. What else do you see?
Wait, does that not take out the M?
Okay, I'm about to take out the M. So M, I know those are glued together, but they also are, they can be broken apart. Like whenever you take that, M will stand alone. You see what I'm saying? It doesn't have to attach to 2. And I know what you're talking about. Okay? So M's can cancel right now. So M's will go to 1. N's will go to 1. Does the P cancel? No. What else do you see? And try to group if you can, but if not, no worries. What else do you see that will reduce? 5 and 25. That's a 5. What else? 18 and 6. That goes to 3. Does anything else reduce? No, right? So what's left up top? 5p. On the bottom? 12. Done. Don't forget you are multiplying this whole time. Okay? Which means reducing as well. Alright, so dividing by the following is the same as multiplying by its reciprocal. Everything else in front stayed the same. We're just getting practice. Because when we do the quiz, it's all about speed with accuracy. What reduces? Try to use what I'm showing you, please. So the 11 and 22. What else? The A's. 5 and 10. Go bigger. All the 2's. because 2 times 2 times 2 is not 6, and I fell for that too myself. 2 times 2 times 2 is what? 8. So be careful with that. Those are simple errors that we can iron out together. So yes, let's go to the 2 and the 6. Okay? So this 2, this 6 will give you 3. Because the thing is, if we do this slow, we're going to get it right. But we're trying to develop strategies to go quickly, so we have more time on the difficult questions. Does anything else reduce? No. So it'll be answer what? 4 over 3BC. Perfect. I think we have 2 more. Right? Oh, 4 more. 4 more, and then we'll quiz. All right. Change them into improper fractions first, and then add them. Now watch. Improper fractions, we multiply, add the numerator to get 14/3. We multiply to get 10, add 1 to get 11 over 2. And I hope you adopted it. You see 28, you see 33, and you see 6. So 28 plus 33, and you get 6. So 28 plus 33 is what? Good. 61 over 6 does not reduce, so that'd be your final answer. You with me? Yeah.
Okay, so very first part we turned 4, 2 over thirds into 14 over thirds. Can you go over that real quick?
Yeah, sure. So the denominator multiplies with 4 to get 12, and then you add 2 to get 14.
Gotcha.
Now check this out. The way this is written, I've always disliked it. And there's a lot of math teachers that also don't like the way this is written. This is written as 4 plus 2/3. The way they have it written right now, it almost looks like it should be multiplication to be 8/3. And that is confusing for students, but yet we taught it that way because that's the way the math textbooks showed it. So FYI, those of you who hate this notation as much as I do, the correct way we should write mixed fractions, in my opinion, are that. But when you see that plus, it's weird, right? But nonetheless, the question that he had, how did you create 14/3? Well, this is over 1. We multiply by a form of 1 so that you get a common denominator, and you get 14/3. You see it? Okay. All right, let's go to 10. So what's the improper fractions for this going to be? 7 over 4 minus, say again? 23 over 6. I hope you adopted it. So you see 42. And then you see what else? Minus 92 all over 24. Okay? So what is this in the numerator? Negative 50, right? Over 24. Can you reduce it? Yes. Now, let's see if you noticed this. This is the first problem that we actually had to think about, can you reduce it at the end? So FYI, if you do my little shortcut, it won't always give you the lowest denominator. You have to ask yourself, is it reducible then? Okay? Just FYI. 11. All right, how many terms do you see in number 11? 3 terms. Okay? 1, 2, 3. Because if you move the 1 over, it'd be minus 1, and the minus is separating all the terms. Pretty much. Okay, do you see what I'm saying? So over here you got 3 terms as well. My point is, a lot of us do not like fractions. And the reason why we don't like fractions is because we don't really understand the denominator. And I think, in my opinion, from that mixed fraction that we just talked about here, you can see what I'm saying as far as the notation goes and what it should be, it is a little bit confusing sometimes. So with denominators, what I like to teach students is get rid of them. That's what makes it difficult, get rid of them fast. Okay? If I multiply all of these 3 terms by one number, with my goal being get rid of all denominators in one shot, it would be 12. Okay? Because technically it's 12 over 1. Follow me, please. The 12 would distribute and reduce this 3 to what? Or the 3 were reduced of 12 to what? To 4. That you will then multiply with that numerator to get 8x. Let me show you that again. 12 over 1 multiplied with 2x over 3. This 3 reduced this 12 to 4, so that you got 8x with denominator of 1. You see it? Now you're going to distribute the 12 to 1/4. What does that become? 3. So minus 3. And finally, distribute the 12. You get 12. Look at that. Much, much easier because we multiplied by something called the least common denominator. That's the method of it, okay? Now you will move the 3 over to get 15, and your final answer is 15/8, which you cannot reduce. Okay, last one. LCD. What could we multiply all these by? 7. Guys, is this legal to me for just to multiply something by 7? The way that I'm doing right now, is it legal? Yes, it actually is, and I was trying to see if I could get people. We know it's legal to multiply any term by a form of 1 at any time. But in this, I'm not just multiplying one side by 7. It's both sides by 7. And that is legal. You with me? For instance, let's say these are equal to each other. And I want to multiply both sides by -1. Are they still equal? Yeah. Okay? That's why it's legal. What do I get? 35x plus 4, because the 7's cancel to 1, equals 21. Subtract, you get 17 over 35. Correct? Yes or no, you agree? Okay. All right, go ahead. That's it.